Hello, Algebra 2. Today's lesson is about chapter 2.7, which focuses on piecewise functions. And these can be a complicated concept, so let's start with an example and make it, I hope, feel a little more real. For example, let's say you have a summer job, and the salary for that summer job is $7 an hour. But there's a special arrangement that you have with your boss that if you work more than 40 hours in a week, you're going to be paid what's called overtime pay, or it's often referred to, based on the amount, as time and a half. In that case, you literally get 150% of your usual pay for that 41st hour and every hour after the 41st hour. So if you're normally paid $7 an hour, from the 41st hour on, you would actually be paid $10.50 an hour. So for those first 40 hours, the pattern's like this. $7 for every hour. So for example, if you worked 40 hours, 40 times $7 would be $280. But starting with that 41st hour, the rate is different. From then on, it's $10.50 an hour, so you're adding more than this. Notice it's always a $70 jump each of these stages, but it's going to be more than $70 here because you start being paid time and a half here. And in fact, if you worked 60 hours, you would get paid $490. Well, if I tried to graph this, those first 40 hours are going to look like a typical linear equation that we've been working with since Algebra 1 days, growing at a slope of $7 per hour. But it starts going more steeply. Specifically, the slope becomes $10.50 an hour once you reach that 41st hour. So as this statement says here, domain becomes very important when you start talking about piecewise functions. The domain where x is between 0 and up to and equal to 40 has one equation tied to it. That's the one with the slope of 7. And the domain where x becomes greater than 40, and anything beyond 40, as this says in blue here, you're going to have that steeper slope of 10.5 or $10.50 an hour. Another example, maybe even more familiar to you. I'm sure you've been somewhere, maybe it was an amusement park, maybe it was some other kind of place, where price was based on age. And here are 4 different possible prices that you might have depending on your age. You could be free, could be $5, could be $12, could be $18, depending on how old you were. If I graphed this one, the price for somebody who was 5 years old or younger is free, as it shows. But then there's a jump in the price to the next level, and that next level continues until you're 12 years old. And then there's another jump here, and that price continues until you're 18 years old. And then there's one last jump here that continues from then on. Adults pay this $18 price. Okay, so I'm sorry, my son and his college friend are down in the basement watching a football game, and I'm sure that screaming was something that you could hear on the video. I guess that they were pretty excited about some play in the game. But anyway, what I wanted to say is that this graph here is often, well, the function itself is often called a stair-step function, and I hope the picture gives a clear reason why it's called a stair-step function, because you're going along at one level and then you literally jump up to the next step and stay at that level until you jump up to the next step, and so on. This is a fairly typical pattern. Like I say, it's often used in pricing, and it's often used in other places where you separate by age or by some other group, where one group has a different price or something associated with it than another group. Okay, so now that I've given some examples, I hope that you're starting to get a sense of the answer to the first thing that I'm looking for, which is an understanding of what a piecewise function is. In a second, I'm going to give you a definition. But let's just back up and talk in general about what I need you to know out of chapter 2.7. 4 things, and as I say, one of them is that definition. The second is, how do you evaluate a piecewise function? How do you look at it and pull out a particular value for a particular situation? For example, how would you walk up to the window at a ticket booth and know what price you have to pay based on your age? Third, how would you draw a graph of that piecewise function? And I'll give you a few to draw graphs of in this video. And then lastly, if you saw the graph yourself, how would you back from that out and the equation, the piecewise function equation, or equations, I should say, that apply to the graph? So let's get started with the definition first. Well, the textbook starts with a first paragraph that kind of gets at it, and let me hone in on some of the details here. First of all, a piecewise function is a function. Because it's a function, a couple of things are true. One, you cannot violate the vertical line test, and that's the reason why I have a closed circle here and an open one immediately above it. Otherwise, the vertical line coming down here would go through that point, and both would apply. That can't be possible in any kind of function. So in every case, I've got closed circle and open, closed circle and open. And in a lot of the graphs you're going to draw, you're going to have to decide which end has the closed circle and which has the open. It's not always going to be the one above. It's going to depend on the particular situation. The other thing about it being a function is when it comes time for you to tell me the value of that function at a particular stage, like I said, the particular price, don't tell me that there can be two different possible answers. Just like you couldn't walk up or shouldn't be able to walk up to a ticket window, tell them your age, and be told one price, and have the kid right behind you in line be told a different price even though he has the same age. If that happened, then price would not be a function of age, and like I say, generally, that means it's not a function. But these are a special kind of function. Piecewise kind of gives the name away. They are a combination of equations. It's never just one equation, it's pieces. And each piece matches a particular section or part of the domain. Might be the far left, might be the middle left, might be the middle right, might be the far right. It depends on how many pieces there are. But each equation is going to correspond to or be tied to some place on the x-axis on the domain. So let's move on from that. If I gave you the set of equations for a piecewise function, and here's an example of what one might look like right here. If I gave you that and then asked you to tell me what f of 0 is, what I'm asking here is, what's the result when x is 0? So for example, if your age is 0, what's the price? If your age is 2, what's the price? If your age is 4, what's the price? Well, notice please, as I said, since it's a function, you can't have both of these underlined. Only one of them can be. So x has to be either less than or equal to 2 and therefore greater than 2, or as I've shown here, less than 2 or greater than or equal to 2. But 2 can't apply in both cases. It has to apply in one or the other. First example here, though, that I have you plug in is x is 0. When x is 0, then x is less than 2. So this situation applies. Don't give me two answers to f of 0. Only give me one. The one where it's the accurate domain. This is the accurate domain for that one. So I put 0 in for x, and f of x, or in other words, f of 0 becomes 0 plus 2, which is 2. If I try 2, though, in this case, well, 2 fits with this domain. It's not less than 2. 2 is equal to 2. So I plug 2 in here. I've got 2 times 2 plus 1, and I get f of 2 equals 5. Last one here, f of 4, well, clearly 4 is greater than 2. 4 fits in this domain, so I should have done 2 times 4 plus 1. Should have gotten 9. So now you do it. There are 2 there. In both cases, tell me what the value is. First for f of 7 for this piecewise function, and that should be a g there, my mistake, I apologize. Tell me what g of negative 3 is for this piecewise function. Hit the pause button and come back. Okay, I'm going to assume you did that, and here are the answers. You should have gotten negative 4 for the top one, and as I say, this should say g. G of negative 3 is equal to negative 9. If you're not sure why those are the answers, hit the pause button, look at them again, and then come in and ask any questions that you have. But now we're going to work on graphing piecewise functions. So in this case, I've got a piecewise function that has one situation when you're to the left of 1, and a different situation when you're either at 1 or to the right. There are 3 steps to graphing these. First of all, I recommend that you graph all of both these lines. Graph all of that line and all of that line. And then mark the place, the break spot. In this case, there's only going to be one. It's the spot where you go from to the left of 1 to at 1 and to the right. And then lastly, I suggest that you erase the parts you don't need, the portions that don't belong. So let's look at this. First, I'm going to graph 1/2 x plus 3/2, and there's that. Then I'm going to graph negative x plus 3, and there's that. Now I've got to mark the break spot. Well, as I say, it changes when I'm at x is equal to 1. You can leave that line on there if you want. It's not going to bother me when you turn these in, but in truth and in the future you're going to have to erase this line eventually. But for now, let's leave it there. That's the breaking place. Now I'm at step 3. I've got to erase the portions that don't belong. Well, for that red line, this one here, it has to be to the left of 1. And the green line can be at 1 or to the right. So what I actually have here is this almost boomerang shape. And that's the correct graph, though I do have to point out that this is one of those cases, they won't always be true, where the two actually meet right at the breaking line. When that happens, it's okay simply to draw in a darkened dot. But in this case, just so you know, that darkened circle actually goes with the green equation, because it's the green equation that had the underlined arrow. Now it's your turn. Hit the pause button, and when you're done, I'll show you the graph of this function. Okay, I'm going to assume that you did that, and here's the graph that I'm hoping you drew. The red equation here goes to the right of the dividing line, and that dividing line is where x is equal to 0. In other words, it's the y-axis. The green equation belongs at and to the left of 0, so it's this that I've drawn. I've erased the right half of the green equation, just as I've erased the left half of the red equation. Notice I've got an open circle for the red equation because the red equation is not allowed to equal 0. It has to be to the right. Whereas the green one, I've drawn in and colored in the dot where x is 0 because it is allowed to be 0. I'm going to ask you to graph another one because I know this is difficult. Hit the pause button, come back, I'll show you this one, and this will be the end of the video, and then I'm going to have a separate second video I can tell in order to fit everything in. Hit the pause button. Okay, I'm going to assume that you did that. Here's the graph I'm hoping you drew. Notice this vertical line here, the breaking spot, is where x is equal to 4. The red equation is allowed to be equal to 4, so that's a closed circle, but it's everything from that point to the left. And in this case, g of x, or in other words, y, is equal to 3. Well, when y is 3, I've got a horizontal line like this. And the second one, the green one, is where g of x, or in other words, y, is equal to negative 1. Again, this is the line y equals negative 1, but it has to be, as this says, based on the domain, has to be to the right of 4. Okay, we actually only have the last step of understanding piecewise functions left, step 4, writing the function when you see the graph. But the technology that I'm using will only allow me to make 15-minute videos. I'm already at 14 minutes, so I'm going to stop this one here and then make a separate one for this last stage.